without ado, Andreas will be here tonight in 6NU to discuss Node Red and enlighten those of us who got lost in his magazine article, which was great, by the
Not
way.
my article, but inspired by my stuff. Put it this way.
There you go. There you go. That works.
Okay. Right, do you want me to grab the screen real quick?
Go for it.
Okay.
The whole desktop, probably. That's the easiest. Okay, let's go and start here. Can you see it?
We can.
Yep.
Okay. So let me do this. I'll give away something up front. This is my Shack remote, and at the end of the talk, I'm getting back to this one here, towards the end of it. Oops, let me do this. So this is about the N6NU remote panel, Node Red, an introduction to all the pieces that go in there. So my name is Andreas Junge. I'm N6NU. I'm a past president of Para. I had a few other call signs, KF6NEB, KQ6WL, which I held for, I think, 3 days.
A whopping 3 days, huh? Yep. We lost your audio, Andres.
No audio?
Yep, now we got it.
Okay. So let me try here. Hold a second here. Let me just make sure I'm on the.
My goodness, you have upgraded your station since the last time I saw it, Andreas. Nice. Last time I knew you were running a second-hand FD1000.
I have to ask, are the Tanners your neighbors?
No.
Oh, but it looks like we've lost Andreas here.
Yeah, it looks like he locked up.
To the great freeze of the century.
Oh dear. Well, we have this from time to time, but typically not with the presenter. Oh, hello. Somebody mute their phone, please.
My guess was
Okay,
that
am I back now?
Yes.
You're back.
Audio and video. That was
Yes,
weird. Of course, it's
Yes,
stable
there
for
you are.
years
Yeah.
at a time, and you do one talk, and it's getting wobbly. Anyway, let me go back here, share my screen, go to the desktop. Okay, here we are. Do it this way. Anyway, I just started doing 1296 EME, and I'm up to 26 countries already in 2 months.
Wow.
And then I'm also pretty active contester, a member of the Pizza Lovers 259, a short PL 259 for contesting. I do encourage questions as they come up, so please feel free to ask me if you don't understand something or need more information. My station consists of the Flex 6700 solid state radio or direct sampling radio, software-defined radio with a Maestro on it. I do have SPE's expert amplifiers, mainly the 2KFA, and Elecraft W2 power meter, a Green Heron controller for the rotator. I'm using a Stepper DB18E with the SDA 100 controller. That's basically, it's a 6 meter through 40 meter antenna. It's 3 elements all the way to 30, and then it's 2 elements of 40 meters. I'm using one of those digital loggers power switches. I use web remote switches to turn things on and off, and that's the antenna again. And I have a Force 12 80 meter vertical dipole with a tornado tuner in it, and then inverted alpha 160 when it's in season. So if you look at my station, there's all these pieces involved, and so there's the Maestro, there's the Flex radio, goes into an amplifier, and then the amplifier does the switching between the DB18E and the Force 12 antenna. It has 4 outputs. There are power sensors in each line, go to the watt meter, and then I can control the rotator and the stepper antenna, basically. And as you can see, these are serial cables. And then there's another serial cable from the Flex radio to the amplifier. So the amplifier does the band switching directly, and then everything else is controlled from the Raspberry Pi here. So, and basically the browser is my user interface to this. So those are the bits and pieces in my station. And so my mission was, when I started this project about 5 years ago, that I needed to tie it all together in some fashion. I think for me, for DXing, which is what I used to do a lot, now that I have 335, there's not too many new DXs, but time to 2DX was critical. When you see a spot, clicking on the spot and everything in the station moving to the right frequency, doing the right thing, hence, without having to worry about it, was my goal. So to click and be the first one in the pile up, or wait for a long time until everybody else is done. So that was my principle, always been my principle, is be on target really fast. Also, the flex radios basically are very good for remote operation. They are basically Ethernet and internet connected radios, and it's very easy to come in from the outside world and work them. And I needed a solution to control everything and make it, as idiot proof as it can be, because if you're somewhere out in the middle of nowhere, you don't have the radio in front of you, everything just needs to work. If you need to fiddle, you lost basically. Then of course, when you work, on the radio doing a contest or remote, there needs to be some monitoring. You need to see that you put out power. You need to see that the SWR is good, basically, so monitoring is a requirement, so you can go pull the plug if something goes wrong. And then as control goes, that the amplifier needs to follow the bands, the antenna switching needs to happen. You need to be able to select power levels, turn the amplifier into standby or amplify, and then turn everything on and off. So those are basically the criteria. That's what I wanted to solve. And so I went on the search for, what to use, how do I do this? And I come from a C++ background. And so, that was my go-to tool. And then it was too much work, actually. I had to write everything from scratch if I wanted to build something. It would be for one platform. And then if you go to another one, if you write it for Windows, then you have to rewrite it for something else. That's hard. And it's hard to do user interface and remote clients and implement all this myself. So I gave up on this idea. So I did a lot of research looking around and found something called Node-RED. And it's a tool that runs on Linux, Raspberries in my case. It runs on Windows, other platforms. It easily handles serial ports, which is important because most of the equipment that's not the radio is serial port based. It does TCP/IP very easily, the internet protocol. You can put user interfaces together with the UI tools, and it can have multiple users logging in and doing things at the same time, which is good if you share a radio with somebody and both parties are lurking. For example, the Flex 6700 radio and others can have more than one user in the radio at the same time, and everybody can have their own little radio and might not be aware of the other person. So that way you need to have basically more than one person in it, so there's situational awareness. And it only requires a web browser as a client, really. So it's remote ready. If you have an iPhone or an iPad, you go to the web browser, you're good. You have Chrome, Safari, Internet Explorer. It all works. And so nothing else to be done on the client side. So everybody has that pretty much. So Node-RED itself, it's a simplified or glorified web server, depending on how you look at it. It's a service that is running on Windows or on Linux and other platforms. It's called a message-based system. It has a point-and-click editor to put code together. Messages are routed from one object to another. That should be object, not object. So it's based on JavaScript on the inside, and if you want to extend it, you use JavaScript. It comes with lots of predefined objects and things you can use. It allows for user-defined functions, and objects, and it has user interface libraries. It's called the dashboard. So that's one of the pieces that I dug out from what's available. And then it's open source and well supported. So if you have a Raspberry Pi, you can use a simple install script to make it run, and it probably installs in less than 5 minutes. So the hardware platform I picked for all this is a Raspberry Pi 4. However, any Raspberry Pi is fast enough for this. The Pi is mostly idling, not doing much. And they're cheap. If you buy a Raspberry Pi, you can get them for as cheap as $35. And I know Linux, I'm comfortable with it. And I know it's also very stable. It's easy to remote manage that Raspberry Pi. If you need to do some maintenance work on the whole system, it's easy to log in remotely. It has a large developer community and only uses about 5 watts of power, and most of the time actually less. And it has Ethernet, it has USB, and you can get lots of add-ons for this one to make it work. So you have lots of choices. This is how a Raspberry Pi 4 looks like. That's the one I'm using. And so as you can see, it's an ARM-based computer. It has USB-C that's getting powered off. You can put up to 2 monitors on it. In my case, it's basically sitting in a little rack mount enclosure, and it's tucked away. It has USB ports, so you can use USB to serial adapters to talk to all the devices, and it has a gigabit Ethernet to push data around in the system. So you can hook it up to the rest of the world. So for $35 for the lowest item here, that's pretty good. I think they go up to $80 for 8 gigabytes, but that's not necessary. So in this case, basically, there's different ways to do this. You can use one single server or one Raspberry. And what you do is you have this one Raspberry, and it has many serial ports built in, like 1 to 4 cable. And so that would talk to the stepper, and another serial port would talk to the rotator controller, the green heron that I have, and then to the watt meter from Ellercraft, and it would talk to the amplifier. And as you can see, there are 2 cables, serial cables going to the amplifier. So one is control for go standby, change the power levels and all the things. And the one that's coming from the flex radio is for CAT, for frequency information. So the amplifier is in puppy mode, and it follows the flex around when it changes the frequency. So there's 2 actually serial connections to the amplifier. So that's one way of doing it. And of course, the Raspberry has to be pretty close to all the devices. It has to be a few feet of distance, and that's it. Everything has to be in one place. And then you can design it in a way, and it's more complicated. And so you distribute this. So what you do is you do one Raspberry Pi per device. And the benefit is now that between the Raspberry Pi and the device and the Raspberry Pi that you're using for the user interface, it can be any distance. The amplifier can be in the garage because I don't want the noise and the heat, and I want to be able to remote control it. So the amplifier in the garage talks to the Raspberry Pi in the garage over a short serial cable, and then it feeds the data from here into this queue over Ethernet. Or the internet, basically. This Raspberry Pi dumps data into this one. And if the Raspberry Pi that controls everything wants something from the amplifier, it dumps a command into the queue. This one will pick it up, do what it needs to be done, and return the data to it. So with this, doing it this way, of course, it's more complicated, has more pieces, but now you can physically move things apart and distribute where they need to be. And it can be any distance. So now,
Quick question, Andreas.
Yes, go ahead.
Can you describe this MQTT? Maybe I missed something. What is it? What device is it?
So MQTT is a service which can run on any of these devices, and it's basically a message queue. So what it does is it's like a feeding trough, right? Basically, there's publish and there's subscribe. So what you do is, let's say this stepper will connect itself to the MQTT queue, which is a service. That's not a physical device. It's a service that lives on there or here or here. So this one connects itself to the MQTT queue and says, I am interested in anything related to the stepper. And there's a topic called stepper. And so you subscribe to a topic here, and anybody could. But so now this one here, the main controlling Raspberry, also subscribes to the topic of stepper, and it can dump commands in here. It publishes stepper related items here, and anybody who is interested in it will get them as soon as they're published, right? So basically, this guy says, I'm interested in commands for me. He subscribes, and this guy publishes them. So he puts them in here, and then he picks it up, and then he will return it and comes back. So this is a broker of information. And so this allows to distribute the data outside the devices and all over the place. I don't know if that makes sense the way I explained it.
Okay, so you're saying it's a logical device. It's not a physical piece that sits between
Correct.
these items. Okay.
It's a service, yes. And it can run on any of these devices. And so, of course, this one, in my case, runs on this one. And so so the good thing now is I can have all these subscribe to basically, let's say, the amplifier publishes meter information when you're transmitting constantly, once a second to the queue, right? 500 watts, 700 watts, 800 watts, 500 watts, and so forth. And anybody who is interested in the SWR values of the amplifier now gets them. They can all subscribe to it, and as soon as it gets published, it gets delivered to everybody. And so this one doesn't have to know who's going to consume the data. It can just blindly dump it in here, and whoever wants the data can pick it up. So give you a quick live demonstration. I hope that will work out. To give you an idea how that looks like, let me, before I go actually here. So I'm using a browser, and the browser will connect to a Raspberry Node-RED server. And there are two URLs that matter here for this. So it's the host name and a colon, and then 1880. That's the default port for a Node-RED editor where you program. And then the 1880 and the /UI is the user interface that gets you to the program that's running that has user interaction available for you. So I'll plug this one into the browser, and then my browser will connect to the Raspberry Pi. So let me go in there and see if you can see this one here. So in my case, so I'm in Chrome, which is a web browser. I connected to the IP address of my server, and it's 1880, and then it is UI, and I have a tab here. It's called Paratalk. So everything in Node-RED is at this point graphical. So you want an inject node like the one I have here. You can drag it onto your paper basically, and then you can double click it and edit what it does. So in this case, let me take it off. So this is one of these inject nodes that I dragged over. And it says there's a payload that when I click on it here, there's a payload that will be sent. And the payload is of the type string. And it says, hello, para. And then this is a node. This is called a node here. Basically, this is a debug node. When you send something to this node here, whatever comes in will be printed out on the side here. So let me do this one. So you have the node, and the output of the node goes to the input of this node. Now they're connected. With deploy, I say I write it to the server. Okay, and now if I click on here, you can see it says hello para. So this node sent a message to this node, and the content was hello para. So this is the basic of it. This is a predefined node. This node is a function node. You can find it here. You can drag it over, drop it here, for example. I did that. And you go into this node here, and there you can do programming if you want to. So there's an object that's called message.message. It has a member called payload. So I take the payload that's coming in from the input and put it in a variable called text. And then I say text is text plus this string here. And then I stick it back in the payload. So I changed something and then I return the message back. And this will pop out on the other side of the function. So it takes stuff from the input, processes and pops it out, and I can program my own thing here. So if you look at this one here, I can take this one out and then say the output from this one goes into input of the function from the output to this input. I publish it. And then now if I click here, the flow goes from here to here to here, pops out and shows up here. And now it says hello para, and it says from N6NU here. So this is how you program basically your custom function. And there's a list of things you can do that are available to you listed here. And there is also something called a manage palette thing. And there is a lot of stuff that other people have programmed already that you can pick from. So you can add functionality. And one of the functionalities I needed to add to get a user interface is called the dashboard. It's we find it here. Here's the Node-RED dashboard. When you add this one, basically this dashboard control to it, it gets you this functionality here. And let's go into this one a little bit. So let's take this one here. Now I take basically, let's say I take a button, put it here, and it's uninitiated. It doesn't know what to do. So I go and say, you live in the para presentation group. So it knows when the screen comes up where it lives. The label is called, let's say, power. And the payload I'm sending is a number. And it's just for grins and giggles, I do 500. So I hit done. So now to see the button says power. And when I click on it, it will basically put the number 500 this way, right? So, and the next thing is you want to, let me show it this way. So now you deploy it. And now we'll add the dashboard to it. There's one here, actually here. Okay, of course it asked me for the username. So this is my full panel, and then the para presentation is here. So now you have a group and it has a button in it called power. I click it, nothing happens yet, right? Okay, now let's go back to the editor here. So I want to do a control that's a gauge. I can take the gauge, I put it here, and then basically I take the power button, and whatever comes out the power button when I click it will be sent to the gauge input. And let me show very quick how it looks like. Oops, hold it. And this gauge also needs to live in the para group. So I'll give you the raw form of this one first. So let's go here. So now I have a gauge here that starts at 0 and ends at 10. And if I hit power, boom, it's 500. But it's only showing 10. But you get, I think you get the idea that I clicked the power button. It sent a message with the value of 500 into the gauge, and it displays it. Now let's go back to here. With the gauge, we can say the minimum display is 0. The maximum display is, because we're good hams, 1500. And show this one here. Now deploy it. And let's look at this. So now the gauge is 500. It goes to 1500, from 0 to 1500, and that's 500 here. Let's make this a little bit more interesting. Now I can put in a slider, this one here, and I can push whatever coming out of the power button. I put it into the slider. I'll show you why I do that. And then from the slider, it goes to the gauge. And what it does, it goes from here to here to here. Okay, hold it. I need to tell the slider where it lives. Otherwise, it's on the wrong screen. Okay, now I have a slider here, and now I can slide this up and down. But the problem with this is that the slider is all the way here, and it doesn't go high enough. So I'll tell the slider that the minimum is 0, the maximum is 1500. 1500. Deploy. Look at it. So now the slider goes all the way to 1500. Or I can say power 500, it goes directly there. So I think you might get the idea how a user panel can now be built up this way. I can take a button, I could copy and paste it in and call this button QRP, and the power I'm sending is 5. And then I make another one, I copy and paste it. And this one I call full legal limit. And I'm sending the 1500 out. And I move this around, go this way. And I take it, the QRP, and put it in here. And the full legal limit, and put it in here. Publish. Oops. Okay. Go to dashboard. And now I can say, I want 500 watts, I want a QRP for 5 watts, or full legal limit at 1500 watts. And so those are the basic building blocks for my control panel, basically. So I think the real hard work in the beginning was to find the right tools that will do the job, and then find how you solve the individual problem. How do I set a value? How do I do a serial port? And so out of these blocks, basically, I built this control panel that you can see here. So this is my control panel that runs my radio station right now. This is live. I can turn on the amplifier. It's in operate now. I can change the power level from high to medium to low, and to medium and to high again. I can take my stepper antenna and go from normal to 180-degree reverse. And you can see red means the motors are moving on my antenna. And as soon as they're green, I know that they're not moving anymore. My antenna is ready. So I'm in 180-degree mode. My motors are ready. And I can go back to normal, put my stepper back on normal. And I'm sitting here in front of the computer, and it's all in the garage. So I don't have to touch it and see it. Here's my rotator control. I'm pointing at 51 degrees. I can go to Europe for 30 degrees. See, it starts moving and indicating that's moving to 30 degrees. And it's not 30, it's 30, it's 35. So I go to 35 here. I can up the value to 35, and now it's going to 35. Well, let's go one more, right? So I can do and the value I can do, I want to be at 47, and then enter it. So now so I can enter a text, I can increment it by 5, or I can just have pre-canned directions for Europe, US, JA, OC, Caribbeans, or South Africa. That's South America. When the amplifier is running, then I can see the power levels coming out. They're also plotted here. I can see the temperatures of my amplifier, and I can see the power actually on the external power meter outside the amplifier. A little chat in here. Basically, if I'm on, it says, hello, are you on? Right, and the other side, if somebody else is in here, they can return to the chat. So there's a minimum chat of, hey, I'm on, I need the antenna, and so forth. Any questions up to this point?
Yeah, Andy.
Yeah, go ahead, Andy.
So these building blocks, like for your amplifier, do you have to write some statements in HTML or something like that? So some basic language that comes with Node-RED, or does the manufacturer supply for you a building block that works with Node-RED?
Yeah, very good question. So this LCD thing, that's a little bit custom made. That needs a little bit more work. Everything else you see is standard Node-RED and the dashboard. No special programming required. You can say in the message, you can set a background to green and send it to the button, and it will change the background to green. Or so this is the only control in here that needed some special programming. That's really fancy.
Okay, Andreas.
Yes.
So are you saying that Node-RED has been kind of in bed with all these manufacturers for many years, and
Oh no.
no?
Oh no. Okay. So no, that's my code. My talking to the amplifier and parsing the data. That I did that, but I'm using a button to a function, to a serial port that talks to the amplifier. So
In other
something like
words,
here. So
exactly. I was going to ask if you could show your Node-RED code, so to speak, for that same dashboard. Thank you. Yeah.
Yes, sure. This is actually the live dashboard, and this one here and this one here are connectors into the MQTT engine. So this is a listener. And if you look at it, it's subscribing to the topic of rotator 1. And if you have more than one rotator, you can go dump commands into it. So here, this one is a publish MQTT out node, and it's basically on the topic rotator 1 CMD. So the commands are put into that queue. Now I'm looking at this one here. If you look at the button, it puts in the value of 130 into the payload and sends it to the queue. Now I need to look for, let me do this one here. Let me try this, 10.0. That's the W2. Let me do this one here. You put me on the spot here. Because I have a distributed system. It's not all on one Pi, right? Let me do this one here. Here's the ping engine. So my the SP amp is done by 187. So let me do this one here. 10.0.1.187. 880. So what we have here is this is the amp control. So this one is listening. Let me say here this amp. There's some magic in here. So here's the receive amp function. That this one connects itself to the amp function queue that's coming from the message queue. And then let's say that the value 130 comes in here that I sent out. And it goes into the switch function here. And it says, if it says write, display, whatever it is, it basically says, if you find write in the string, go to output 6. If it says display, go to output 7, and so forth. And here you have to have output 1, 2, 3, 4, 5, 6, 7. And then it goes to this function. So for the amplifier, for example, so it's operate, right? And operate generates a string that I need. So this is the preamble for their control code. And then this code will turn the amplifier into basically into operate mode. So and then it takes it to a def USB. This is a USB to serial converter, and it dumps that one into the amplifier. So this is sending the command to the amplifier, and then there is a listener here that listens to the serial port coming from the amplifier, and returns back what it does. So basically, it strips off the header that's coming out. So this is JavaScript. I'm slicing and dicing the strings coming back, and then I'm taking the result from that back into the MQTT as a status. It dumps whatever came back into the queue. So that's a round trip. So it let me see. It listens to the message queue. It parses the data coming or the command coming in. It sends the command from the serial port to the amplifier. And then the amplifier listens to that same serial port, serial port, gets the result back, processes the result, and sticks it back into the queue. So this is basically one specific the Pi doing nothing but amplifier. The next, let me hear. What's the other one? Is this? Look at this one here. So this is for the W2 from the watt meter, something similar. Basically, I'm looking at the serial port coming from the watt meter. I parse the data, and then I'm sending it out to the message queue. And here, basically, I'm creating the command F and S, or the command F is asking for data. So the SWR request puts an S, the letter S into the buffer, and then sends it out to the serial port here. And then the serial port receives this one back and processes the data and puts it into a message queue, one for a W2 forward and one for reflected. And I just subscribed to anybody subscribing my network can get the data from the watt meter. Does this help?
Yeah, Andreas.
Yes.
Yeah, this reminds me very much of using LabVIEW by National Semiconductor about 25 years ago. But as I recall, so long ago, you didn't have to do anything to write this low level, so to speak, interface at the instruments that you connect to. They come with certain sets of control statements. And I think it was over GPIB. There was nothing like this.
Yeah.
Yeah. Okay.
Yeah, but it's different. A GPIB, serial port, or however you get your data to the other device, right? Whatever, that's a magic wire in the middle, right? So, and then this is the rotator command. If you look at this, it builds a string. It says, it's doing some magic, and then getting the data from the rotator is sending AP, and then you put the heading in. So AP space 130 carriage return, and then the rotator will go to that location. And it's picked up from a message queue here, build the string, and then send it to the serial port, right? And then whatever comes back from the rotator goes back into the message queue for the rotator. So it's going around. On the flex radio, basically the flex radio data is a UDP port on 4992. So what you do is, you're receiving UDP messages. You look at I'm checking for the serial number of the radio, so I'm decoding the right radio. If there's more than one in the network, then I split the string of what I get back, and I'm using spaces to separate it. And then in the switch statement here, I look at it, is it my call sign, my serial number, the GUI client, it's all the data coming from the radio nickname, is it in use or not? All this data is coming out of this one here, and then I'll take that data and display it on who's the client one, who's the client two, and so forth. So there's programming involved, and you need to push some data around, and So there's nothing radio specific. I'm getting to this later, but any more questions regarding the bits and pieces involved? So you have certain controls available to you. You put them into your, that's called a flow, and then you configure them to what you want. And you get basically you build what you need out of the bits that you have here, right? And if you look at my control panel itself, actually, it's a button, 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 right? Button. There's not that much in there, right? And this is one of those gauges basically that gets the data from the rotator and it can display. So
your control panel is not controlling anything but the ancillary items around the radio, not the radio itself.
That is correct. Could I do that? Yes, I have chosen not to. And there is so I'm getting to that a little bit later, but there is so I gave this code to the guys that did the article in QST. I let them, so I started this 5 years ago. They are in the Flex community like I am. I'm one of the alpha testers, so I have the privilege to have access to the developers of Flex Radio, and they every so often throw something over the fence as, can you try this? And if it blows up, yeah, okay, then you need to send my radio in or something like that, right? On the other hand, is everybody in that group is very involved in trying to make this radio better and more usable. And I'm really close to getting them to allow me to do some of these things. Basically, let's say let a Maestro connect to an MQTT server and give me the ability to, let's say, push a function key and it asks me for the number, let's say 125, and hit enter in the Maestro. And then it dumps that number into a MQTT server. It doesn't know what it's for. I know it's for the rotator, right? So I want them to put that into the radio, that, now if you have a Maestro, you push a function key and you can do your rotator control from within the Maestro. Just think about it, right? And so there's two guys, Dave DeCoons and Mike Walker. Both of them are very much, so Mike works for Flex Radio, and Dave DeCoons is like a fanboy like me. And so they took it and worked on it, and they used it, and they go like, hey, how do we get it to more people? And they're like, what do you think? And they say, oh, so I'm getting to this later, but they created a community around it on a mailing list thing, and so they published it, and now people are enhancing it. And I think as of last week, there's actually now officially a Flex Radio control checked in and usable. So it actually, even that will be, and to Andy's question, it will be selectable from within the Node-RED IDE, and you can say there's a Flex Radio control, and you can pull it in that way. So it's getting traction, put it this way.
A question on that. You mentioned Node-RED IDE. Mm-hmm. Is there another IDE except for what the web browser provides us here? Or
not that I know of.
Okay. Just making sure, because this seems full featured. But since you mentioned the IDE, I wondered if there was a particular tool or like specific tool. No, it's all here. Excellent.
Yeah, it's all here, and it's a fair question. This is one of these things. It's web only. Maybe one of these days somebody decides it, since it's all JavaScript and it's all in JSON encoded. The whole code, basically, if you export it, it's just a big JSON string, with all the code in it. And I'm sure somebody could write it. I don't know if they want to, but right now, this is the only way for you to code.
Okay.
It has the ability to export and import code.
Excellent. Have you run into any JavaScript compatibility issues between different platforms? So far, we've been pretty, Raspberry Pi focused, but so the code is running on the Pi, and you're using it from different platforms only through the web server.
Correct.
Yeah. Okay. So I guess that does eliminate most sort of interoperability compatibility issues.
Correct. And
the JavaScript is the JavaScript is running on the browser, right? So you have a browser compatibility question more than a Pi compatibility question.
Yes, and I'm
To,
using
Nico.
Chrome, I'm using Safari, and I'm using Internet Explorer, and all work. I'm sure you can find something more obscure that might blow up here and there. I don't know, yeah, but it's so far I have not had any problems. I use the control panel from my iPhone and iPads. I use it from my Mac with Safari. I use it for my Windows machine with Internet Explorer, and as you can see right now, I'm using Chrome on my Mac.
This is really brilliant. The QST article didn't. I don't think it did. You know, the full service for how nice this Node-RED relay is. What it can do.
Yeah, and you know how it is, right? I mean, you slept that ketchup bottle for a while, right? Until you figure it all out, and then some other people go, "Oh, it was easy," right? And it's just finding all the bits and pieces, and you know, finding a platform that checks all the boxes, right? Can I do serial? Yes. Can I do TCP/IP? Yes. Do I have gauges? Right? Yes. Do I have push buttons? Yes. Do I have sliders? Yes. Do I have, right? And more, right? For example, I'm into EME now, right? And for EME, I wrote this one here. I have my moon data thing, and there's actually control that gives you moon data, and I'm just using the same, you know. I turn on dish tracking here, and then my 3-meter dish in the backyard starts turning and elevating. I don't have to do anything. That thing just follows the moon, right? And so it's still at 18 degrees, and all the data is here. So that was maybe 10 minutes of programming for me.
I was going to ask how big of an antenna you use for the 1296, but there you go, 3 meters.
Yes.
No, that's really good size. Yeah.
And
How much power? How much power are you running?
350 watts.
Okay, thank you.
Yeah, I'm getting out. I don't have problems.
Yeah.
And then there's another one here. This is a grab bag of things that I have for maintenance that are not pretty, but I have a ping control that shows me all the Pis that are involved and if they're pingable or not. As you can see, that the 6700 is not running right now. And I can see all these, so I can see the health of my devices. That the radio is not on right now, so it's not displayed. I can reset the Pis remotely. I can turn them all on and all off. I have a power switch here. There's a digital loggers, and these outlets basically are switched, in my case, 240 volt outlets, because I can turn the amp on and off. The 240 of the amp I can turn on and off here. My 12 volt power supply is running off 240. And then there's other outlets here that I'm not using right now. If you can click on this one here in outlet 8, so you turn green and turn green. If you were in my office, you hear click, click, these outlets coming on and off. So it's complete remote control. There's more stuff about, and then I have some more for the stepper here. I can home it, I can calibrate it. So it's available, but yeah, so and then this is the full remote here, basically.
So how are you turning your radio on and off?
Here, remote on. There's a connector at the back of the Flex radio. It's called remote on. It's a RCA cable on it, and you just have a relay to short it, and then the Flex radio comes on. That's just the Flex radio, and then for a crowbar solution that's a little bit more brutal, basically, it's on the main 12 volts, so I can actually shut off all the power and bring it back online that way.
So when you can tell when it is finally fully online by your radio area there.
Yeah, it shows in what's the call sum, the nickname, the IP it got, the version is running, and the status if it's connected and how many are connected.
Okay.
I can see that here.
And for your power switches here, are you? This is kind of getting off topic. I'm sorry, we are kind of diverging, but this is very interesting stuff for me right now. So for the power switches, are you using those? I think the brand name actually is Web Power Switch.
It's called
the Ethernet
digital loggers. Okay.
Oh, digital loggers. Okay. Yep. Yeah.
Let me do this one here. I think I can show you how it looks like.
Yeah, I'm familiar with those. What we
Yes.
see in the pictures now. So I think
Yeah.
their brand name. Yeah.
And so I have the one that does 240. And by the way, the owner of this place is super nice. These guys are in Santa Clara, I think, and he's a ham.
Oh, excellent.
It's
So you
excellent.
said you have one that does 240, but it still has the like US 240 socket, right? It's not the.
It's was it C19, I think.
Okay. Because I looked up their power switches online. I didn't see anything for 240. It was all 120. 120.
Yeah, they have one that goes from 80 volts to 240.
Oh, excellent. Thank you.
Let's finish this one up here. 240 volt. Let's see. Yeah, digital web power switch. Yeah, there you go. This is the one.
Oh, it's like a rack mount. Oh,
it's a rack mount. It does a Wi-Fi, and it does wired, and it has actually the power switch has MQTT built in, so you just set the MQTT and it fits in my environment like a glove.
Okay.
So it all works. So this power switch, and then it has the basically outlets in the back here. I don't know if they show them, but that turns on the power. I can turn the whole station off. I can turn the whole station on, including the amplifier.
And for your 12 volts, are you using this power switch?
Yes.
And power switch comes on, the whole 12 volt line comes on, or did you have okay, yep. So no separate switching on the 12 volt line itself.
Not right now, but I could.
Yep.
And so you can actually turn on different power supplies if you want to, with different outlets in the back. There's like 8, right?
Yeah. Okay.
Yeah, and I'm using the 240 volt version, and so my power supply I'm running off 240. So my whether the Astron or whatever it is, it has 240 input, so it feeds all of this.
Excellent.
And so far so good.
Yeah.
So let me go back here. So so let me go back to my presentation now, or do you need more information on this particular one here right now on the implementation of it? Any more questions? Otherwise, I'll go back to my presentation. Okay. So this was this one here. So this is how it looks like. So what happened was, so I started 5 years ago, and several people said, "Oh, gee, wouldn't it be nice if I could use this?" And so, okay, why not, right? So David DeCoons and Mike Walker, and these are two guys that wrote the article, basically said, okay, you can share it if you want to, find a way to do that. And so they published the QST article. There was some mentioning in the National Contest Journal about this. And in July of 2020, they set up a groups.io community, and they uploaded the code up to where we were at the time. And as of today, actually, there's 808 members on that group. So it's 808 people actually went to the effort to subscribe to this group. So we're really getting critical mass here for getting things developed. So right now, as I said, as of last week, there's a control for the Flex Radio, which will actually be part of the selectable items to put into Node-RED as a component.
The article on QST had anything to do with your bump in members?
You know what? we should look that up, actually, and I really hope so. People are reading it. I get feedback. I get contacted, and I'm glad to see that people reading the magazine. Absolutely. Yeah, and if you look at it, so this is the Node-RED ham radio landing page on groups.io, and I'll be if you want to put it in a newsletter, we can put a link there. Otherwise, send me an email. I'll be happy to reply you with the information. And if you get into it and want to use it, or you have questions, I'm happy to help you solve your problem. If there's something that needs to be done that hasn't been done before, I think there's always a solution. And so thank you. And if you have any questions, I'll be happy to answer. It's okay to wake up now.
I have a quick question on it. How do I connect to your station, dude? I want to work it from here.
You could do it today.
Cool.
John, can I put you on the spot? W6FEL. Are you still here, John? So John, W6FEL is quite a user of my station. So there is a way to, it's called SmartLink from Flex Radio to, if the radio publishes it, you log in. If you have the same login, you can see the radio, bring up Smart SDR at home, which is the software piece of the radio. You run it on Windows or on your Mac or even on your iPhone. And if you are part of that login group, it will show up as an available radio, and you just click on it, connect, and you're done. And then there is a way for you, if you know how to access this control panel, and you can do everything from there. That's correct.
Too cool.
Let's talk.
Two questions related to that. What is the DX record that you have accessing your radio from remotely? And have you worked all states, from all states, working your radio from hotel rooms or wherever in all states? You know what I mean?
Have I done anything tricky with this? Well, I think so I don't use remote stations all over the country. I just use mine. So the question is, have I worked? I think I have worked some really tricky stuff while I was on the road and not at home, but from my station at home. Yes.
Well, I think Shree's
So from how many different states have you accessed your station at your home?
Oh, it just no. This is a very tiny group. It's just one other person and me. Right now, it's not a not for sale, not for If there's a rare DX out there and you need it, I'll be happy to let you use my station.
I think Shree's observation is for you to work your station from every other state in the union. You
okay,
see,
all right.
the reverse of WAS.
Okay, Shree. I know you're a good tricky thinker. If you the Shree, I think you are. Right? Didn't we talk about some really tiny web servers while we're at field day or something like that?
That's right. Yep.
Okay, good. Then I remember. Yeah. No, that's a good one actually. That's
create your own award.
Yeah. No. I have to go and drive across the country. Hit every state.
We don't necessarily have to drive, but you have to get there. Yes, one way or another, whether it be fly, drive, hitchhike, whatever.
Hey, Jim's
here's what you can do. You can VPN to different states, and then from there you can come back to your IP address and then work your home station. It's got nothing to do with ham radio. We are going way out right now.
Yes,
I'll return you back to your talk.
That's a whole new level of angry people out there. You're doing what? No, that's not right.
Yeah, but to do it really right, you would need to do it through a ham's location in a given state, not just some random VPN from some state.
Yeah. Well,
so here's question. It really has more to do with remote station control than Node-RED, but so having the reliable internet access and having your Raspberry Pi running, that's sort of that's a requirement for any of the Node-RED stuff to work, to put it one way.
Yes.
Just in your case, are you also controlling your Raspberry Pi power supply, or is that just always on USB-C?
Nope, I can turn them on and off.
Okay, so you have another power switch.
Yes.
But see, you get to kind of into a loop. So
I've locked myself out before.
Exactly.
I closed the door and forgot that I locked it from the inside. It happened to me. Yes.
Yeah, but of course those web power switches are nice because you can set the default condition. So whenever it comes up, that
Oh.
power rail comes on. So is that what you're doing, or?
Okay, so different thoughts, right? I have them on go to the last state where you were.
Oh,
That's one thing. I do very big computers for a living, and
Oh, yeah.
the default there is for me, power goes out, you stay off, because you don't want to have a megawatt of power being sucked down all of a sudden, when you don't expect it. So it depends on what you do. So by my setting, that's one thing. Another nice thing about these web-based power controllers is like the digital loggers. You can have them ping a certain specific IP address.
no.
And if they don't get a response back, let's say from your from Google, like maybe the modem is gone, right? And then you can just power cycle the modem and see if it comes back, right? So and reset it that way, and you can do different levels. And these digital logger switches are actually Lua scriptable. So there's a Lua script engine in there, and you can you can go wild on it.
Nice. Thank you.
Yeah.
They just need to come up with the version with the European plugs, so you can take one of those over there and leave it and build.
No, you can actually. There are the plugs are not fixed. You can do a Shuko, put it on there, and on the C19, they're all pluggable. They're like a cold, like a normal,
Sure.
They're just C19s in back. There's cables from C19 to Shuko, right?
Oh yeah. If you just do like little, not pigtails, but
Yeah, like a pigtail. They're all pigtails.
Yeah.
There's no cables on the switch. You have to buy the pigtails, and a lot of them are plug in and cut off and put like a L1430 on, for example. Yeah.
Yeah. Well, I need to look into that C19 you said the model is. Yeah.
Yeah, I can, and I'll be happy to show you what I have there and take a picture and make sure.
Awesome. Yeah.
Yeah.
My thing is, I'm building a remote station here, but I need to take it with me on a trip to Europe and then leave it there and leave it running there. So it's a little bit it's a little bit of challenge to get all the 220 or 240 volt stuff getting going here, make super sure everything works, because I have very limited days over there where it just needs to work.
Where in Europe would that be?
Sorry.
Where in Europe is that?
Oh, Finland. OH.
Oh, Finland. Okay,
Yeah.
very good.
Ocean Henry.
A friend of mine, Jussi Kukkonen.
Yeah.
I hang out with him all the time.
Yeah.
Okay.
My European call sign is Ocean Henry 1 Golf.
Okay.
Yeah.
That's a good call sign.
Well, you're going to need to make sure that there's somebody local that knows all the ins and outs. So when all else fails, you got eyes on.
Well, there's that, and all I can tell him is unplug and replug in.
Right, and let the digital logger switch be that first step for that. If you can't ping, shut everything down, bring everything back, and then so that would be the first step. Yeah. As I say, it's I learned a lot while doing this. It's all about it's all there. It's not that hard. You just need to figure out where it is and how to do it with it, right? And everybody use the same water to cook their potatoes, right, or boil their potatoes, right? It's not that hard sometimes. So you need to figure it out, and once you are past that step, it's easy, right? And again,
yourself, buddy.
yeah. Well, once you figure it out that you can use a plastic bag, tied up to a little rope, and the vacuum on the other side makes this, makes the pilot line go to the other side,
So what logging program are you using, and do you access your logging program remotely, or do you operate it locally and then update your log?
Good question.
Yeah.
So I'm using N1MM. And N1MM is actually tied in with my Node-RED. So when you in N1MM, you can type the heading of a call sign. That's a Control J, I think, something like that. Control N. So if you have a call sign in your log and you do Control N, it sends a TCP, a UDP command out on the network, and I'm listening to that, and I stick that one into the rotator. So I can take N1MM and make the antenna swing over to that call sign, for example.
Cool.
Yeah. So again, it's like be the first one there, right? Just to work the DX before anybody else shows up, and then you're in and out, and you were never there. And so yeah, so it's N1MM. I do run N1MM on a local computer. When I'm remoting, I do VNC over to that login computer that I have and run everything from there. So FT8, no problem. CW, no problem, right? It's keyboard CW from N1MM anyway. And I probably have a hard time finding my microphone right now, but you could do that one as well, probably. So yeah, N1MM, it's free and it's fantastic.